Welcome to our kickoff event for the new Ansys Discovery. Hello Urka.
Hello Mark.
With great pleasure we would like to present you the Simulation Innovation of the Year, Ansys Discovery. With Ansys Discovery we will not only develop better products, but we will also have much more fun at work. If you want to know what the new Discovery offers and why we are so enthusiastic, then you are right here. What will you see? We start with an overview from Urka Wang. Model, explore, analyze. You will see what the highlights of the software are, and you will understand why this is such a cool new approach for us. Afterwards I will show you the software so you can get an impression of the look and feel. One of our customers, Hawi, has evaluated the new Discovery. You will hear and see from Mr. Mako what the test has revealed. And he also talks about the potential he sees in Discovery for his company as head of simulation. And now, Urka, it is your stage.
Thank you, with pleasure. What does an engineer need if he wants to realize his great ideas in a product? Of course he needs a tool with which he can change his geometry very quickly. If he has a lot of ideas, he would of course also like to be able to evaluate very quickly whether they are good or not. Then, when the best idea has won, he would certainly like to validate how accurate the result is. So, the three important terms are easy modeling, quick evaluation and accurate validation. We will also see this in the next examples. Here we see a great product developed by a good engineer. Now he would like to know what the stress distribution under inner pressure looks like, and instead of waiting many hours, he can use the new technology to analyze the stress distribution immediately. So now the engineer sees that the notch stress is not correct, because there is no rounding at all, so he needs a tool with which he can change the geometry very quickly. With this tool he can immediately insert a new radius in the geometry. And at the same time he can immediately simulate the stress distribution again thanks to the new simulation possibilities. So, he can test and validate different variants. Then he decides on a very specific good variant. And now he wants to know exactly how accurate the result is. In other words, at that moment he needs a tool that allows him to simulate and validate the result with very good accuracy. For this purpose, the Ansys Mechanical solver is used here, and a simulation is performed with it. In the early phase of development he will not yet know exactly when he wants to model geometry, when he wants to validate and when he simply wants to evaluate the idea. This is a dynamic process. Therefore, he can decide at any time what he wants to do, because it is not the software that decides, but the smart engineer. The engineer can say when he wants to model, validate or evaluate. The software does exactly what the engineer needs. In the geometry state the engineer can say, okay, now I'm satisfied. Now I want to see the stress distribution under inner pressure. Zack. And now he can see the stress distribution. Thanks to GPU technology, he gets a result within a few seconds. And because the result is available so quickly, it is possible to test different variants very quickly. For example, the notch stress. There you simply insert a radius. In the moment in which this radius is inserted, the result is already there. So, the engineer can quickly test different variants. Then he decides on a good variant, and now he wants to know exactly the stress in this region. For this purpose, a calculation is performed in the background with the Ansys Mechanical solver. Now you might think that the software can do all this very well, but it is very difficult to operate. No, it does not have to be. With this new software technology, a very complicated task can still be solved very easily. This is the entire user interface of Ansys Discovery. Above you see a modern menu for those who are used to such a menu. You can work with it. For those who work in a very structured way, a tree is available on the left side. But very special and new is the heads-up display. This knows what the user wants to do. And that is why it communicates with the user. Here, for example, we have a structural mechanical task. When you click on a surface, the software asks what load you want to apply. Then the engineer says, a force. And the software asks, on a point or on a surface. This is how a software-human communication starts. At some point it may happen that you don't know what the next step is. But that is not a problem. Just press F1. At this moment the software shows you what is possible in this state. So, don't worry. Whenever you don't know what to do, you simply press F1. This is more than just a help. You get a complete overview of how the software works. For example, I would like to know this pull function. What the help shows is not only an explanation but also an animation how this function works. For example, if I want to make several drillings, I click on it and the software shows me how it works. This is a very modern and dynamic help system. We have tested very many applications with different physics, and in this presentation, I would like to show you two examples. The first example is a fluid example. Here we see the geometry state. To simulate a flow, I simply extend the pipe. In this configuration I can do a fluid simulation in seconds. So, I can examine different variants. Now I say, this is a good variant. I want to know the exact velocity distribution. For this I go into Analyze and create a very good fine mesh. And then I can perform a very accurate fluid simulation with the Ansys Fluent Solver. Not only that, that is not the end of the story. The user can even go so far as to hand over the whole thing to an expert. There is an option to pass everything onto Ansys Fluent. Just click and the model is exported to Fluent. The second example. Let me show you a structural mechanics example. This is the geometry, and we already know that it is very easy to modify the geometry. The simulation of different variants is very fast. That's why the engineer can quickly evaluate different variants. And another possibility that the software offers is topology optimization. I can tell the software that I want to have a geometry optimized under a certain load. Now I get a geometry from the topology optimization. What's great is that I can convert the suggestion into a CAD at the push of a button. Now I can replace the old geometry with this newly created geometry and perform a nonlinear contact simulation for the entire model in Ansys Discovery. Of course, I get a nonlinearly calculated result and a good local stress distribution. Now comes the next question. So far, everything is great, but I want to continue in Ansys Mechanical and do some other calculations. Is that possible? Yes. You can simply export the model to Ansys Mechanical here. What happens? You are now in Ansys Mechanical. With an import like this, you always wonder what has really been imported. So here from Discovery to Ansys Mechanical, this has been imported. Geometry, material, mesh, contacts, boundary conditions and loads. The entire calculated model has been imported. Now you can continue with these imported things in Ansys Mechanical and calculate more things. Currently there are 4 physics in this release. Structural mechanics. This is linear and nonlinear statics and modal analysis. Fluid analysis, thermal analysis, and thermal mechanical coupled analysis. Let me summarize. With Ansys Discovery we model. We simulate very quickly, and we validate very accurately. We don't have to decide on many software environments. We have everything in one environment. You will have a lot of fun with that. Thank you.
And I would like to show you this joy with Model, Explore, Analyze. Let's have a look at it in a demo. Within Discovery, I have chosen an example from the Engineering Office Brandt. The Engineering Office Brandt, Michael Brandt, has published a book, Understand Physics, Construct Better. And there are many construction principles in it. And it always follows the thought that if I understand physics or let myself be guided by physics, then I can also make better constructions. And this is exactly what the Explore within Model, Explore, Analyze in Discovery makes possible. Hence this example. And it is all about optimal stress distribution and bending. In other words, to optimally design the cross-sections. Let's have a look at this. Within this assembly, we are not talking about the entire assembly. Instead, I will select the area that I want to simulate. I don't need the hydraulic cylinder either. Instead, I want to apply a force there. I apply 255 kN. The direction is okay, after I have turned it around once. And then I still must fix it. So, I take these support points here. 1, 2, 3 and 4 and apply a fixed support there. Now I immediately start the analysis and look at the first result. I am interested in the deformations and in the stresses. First, the deformations for reasons of plausibility. The animation looks good. And second, the von Mises stress. And then you can already see that it is about this connector here. I must optimize it. And the first thing I could do is create a larger cross-section. I set the yield strength in the legend to 250 megapascals. And then I can take the edge here at the front and widen it properly so that we have more cross-section available for bending. Explore gives me immediate feedback. Okay, here I am already successful. I could follow the same thought back here. How do I provide more material here? For example, by entering a blend radius. And the result is quite satisfying. Better than before. But there is more to it. I take this radius here and orient it concentrically with the cylinders here. This of course results in more material. And a larger cross-section. And what effect does it have on the stress? Wonderful. So, 250 megapascals, we are probably very close to that here. Looks good. Here I have a neutral fiber, as you can see. And I could save a bit of material there now. Now I'll make a circle here. 60 mm. And the second smaller one 40 mm. And from that I can now create slotted holes. I might switch off the solver for a moment, so that it doesn't always calculate. And then we'll take this slotted hole here. Or this hole. We take the axis. I want to draw it in this direction to a slotted hole. And then I make it 80 mm long. I do the same here in front. I take the axis. Say that I would like to pull it in this direction. And make the whole thing 80 mm long again. Good. Now I have saved material. In the neutral fiber. Let's see how that works out. And we will look at the result again. At the point of interest. And it looks similar to the one before. So, this has not changed so significantly. So that was a good change that we made. And of course, it saved us material. Now I want to have an exact result. So, I will go to Analyze. I want to be able to refine this locally. For example, to determine the exact stresses. So, let's look at this location. And at this point I want to do a local mesh control in the simulation. And at this point, for example, an element size of 4 mm. That's all I have to do. With this setting I can run the whole thing now. And of course, it takes a little bit of time now. He must mesh and calculate. I have already prepared this. I'll open the model. And as I said, it is now meshed and calculated. Now let's look at the part of interest. And if you take a closer look now, there is a small numerical value in the legend. This is the location where I just moved the mouse over. So, we have reached 250 megapascals here. Now the question is, how could I provide more material now? And a simple answer is, I put a larger radius in. Do I have to go back to the model for that? No. I simply change the radius here inside Analyze to 110. It takes over the geometry change. I start it all over again. And now run the analysis again with the change. That takes a little time now. And I now look at the finished result. And if you follow the probe again, we now see that we have reached 230 megapascals. So, model, explore, analyze. Editing the complete process through geometry. Try it out. And then, at the end, do a really accurate analysis. Refine a local stress. And then there is even the clue that model is not separated. Model is available for us within Analyze, so that I can give my ideas free rein at any time. So much for the first example. I would also like to show you a fluid example. And here I took one from our seminar on the new discovery. It is about a distributor. The air flows through it from one side, and has 4 outlets. And the flow should be as even as possible. In this context, we are now looking at model, explore, analyze, of course. So, I will set this up. So, we have these 4 outlets here. We have the inlet here. And I start with an inlet with a mass flow of 1 kilogram per second. The whole thing is water. In the default setting. And here on these 4 surfaces I now apply 1 outlet each. And then I calculate and explore. I immediately get an impression of what is happening in there. And you can already see that the solver converges here. But I can already make first investigations. Where do I have high speeds? I can see that very well with streamlines. Or a representation that I personally appreciate very much. This is the representation of the highest values at each screen point. This way I can always look into the structure. And there you can see very nicely that I have a range of high speeds up here. What you can also see is that I obviously have a dead zone here. And there in front it is also very dark blue. There is also a dead zone. And maybe I want to optimize that. We see it in detail in the dead zone. For example, I could display the vectors. I can't see too much now. Maybe better the display with the particles. And that looks great. Here I see how the fluid recirculates here. In the end I am interested in a result variable. Namely the pressure loss. And this is entered into this diagram when the stationary solver is converged. And we currently have a pressure loss of 12 Pascal. And now I want to draw on this result. So, I want to be guided by physics and make a better model. I will build a spline here, which follows this dead zone. And just cut off this area of the geometry. Then it looks much better. And I avoided the dead zone. And if we now take a look at the velocities. Well, we had a speed of 0.53. Now we have a little bit more. It rises to 0.55. And that's this range up here. So now we might consider if we give it a little more space. So, I just pull the cross-section a little bit apart now. Maybe even to the left. Let's take this area and pull it out a little bit. In such a way that we get a slightly wider cross-section there. And now let's take a look at the speed distribution. Or rather, what pressure loss will occur at the end. We can now have a look at the whole thing in the diagram. You can see very well that this region of high speed has indeed changed significantly. And the pressure loss, I'll switch it on right away. And then we hope that the result will be shown to us here. In the meantime, we could perhaps look at another result variable. For example, these projected streamlines, that is also very instructive. Here you can see this flow behind this disturbing body. And now also the solver is converged. And apparently, we have found a trend with which we could actually significantly reduce the pressure loss. That is good. But now I want to have an exact result. So, I want to determine the pressure loss exactly. That's why I go to Analyze and run this analysis with Analyze Now. Of course, that takes a little time. It must mesh, it must calculate. I have prepared it before. That is the result. And let's take a quick look at the mesh. Such a beautiful mesh that we get. And you can also see very nicely these prism layers that he has built up automatically. And if we now go back to the results again and look at the pressure drop, then we see here, in orange, the trend that we found with Explore. And then we see here in purple, which is the color of Analyze, also the corresponding result for this design. Provided that we calculated it with the exact Fluent solver and with this very good mesh.
Simulation used to be my daily business. Now, it's more my job to assess whether and how tools fit into our process and how they help us in achieving our company goals. I want to show you which role the new Discovery plays for us in that regard. HW Hydraulik is a middle-sized company in Germany and one of the leading manufacturers of hydraulic components and systems with 2,500 employees worldwide. Due to the consistent use of steel, the hydraulic components can be designed for high pressures and very compact builds. Due to the very high production know-how on state-of-the-art machines, we can produce our valves nearly leakage-free, and it allows us also to adapt them to our customers' requirements. Simulation plays an essential role in this process. Simulation clearly contributes to shortening the time for development. It allows us the creation of new ideas and development approaches. A development process depends on many factors. For example, the delivery time, capacities, test benches, and so on. A traditional development loop in hydraulics with physical prototypes can take several months. Our C-level is therefore interested in shortening the development cycle. For the qualifications of prototypes, test bench capacity and manpower is necessary, which means high costs. In order to reduce these costs and generate synergy effects, we have taken certain steps over the last years. Firstly, the simulation and testing departments have been merged into the Simulation and Testing Center division. Secondly, we have successfully established simulation in the development process. A development loop with virtual prototypes can now be realized in a few weeks. Now, we see the requests from our design department for simulations are increasing, which is good. But this leads to bottlenecks in the simulation department, which means additional waiting times of some weeks. How can we resolve that in the next step? We can either increase headcount in the simulation department, or we deploy suitable simulation tools to the designers and design engineers. At HW, we have decided for the second variant with Ansys Discovery because it is more sustainable. It offers the advantage that the designers can carry out variant studies themselves quickly. The younger engineers come already with the necessary qualifications. They are able and they want to simulate by themselves. Empowering designers for simulation also frees up time for the analysts. That allows them to focus on their expert tasks again. We are excited about Discovery. For us, it is the perfect tool to take these steps. Innovation needs innovative thinking. Discovery allows innovative thinking. And for me, simulation is the key for innovation in medium-sized businesses. Already last year, we were looking for a tool that would help our design engineers to solve standard tasks in the CFD area on their own. After extensive evaluation, at the beginning of 2020, the Discovery product family emerged as the winner. The decisive factors were the ease of use and speed of Discovery Live, and also the speed and reliability of the implemented high-fidelity solvers. A positive side effect? With this package, our designers can also do mechanic simulation with more functionality than the current CAD tool is offering. With the new Discovery, our designers now have all of that in one modern user interface. CFD and mechanics to test ideas themselves, and it's extremely clever that I can change the geometry right away. Discovery already has more functionality than typical CAD integrated tools, and it is still extremely easy to use. The reliability and speed of the solvers in Analyze is also important to us. Our experts can hand over the standard tasks with confidence. And last but not least, the Explore stage simply calculates incredibly fast. No more waiting time. I think that's pretty cool. Obviously, Discovery will give us a better understanding of the physics in our products. This means for us better product performance, higher efficiency in development and shorter development cycles. But there is more. We can better allocate our technical human resources. We can meet customer requirements more precisely and avoid over-engineering. We eliminate uncertainties because the designer dives into the whole physics very early in the process. During our evaluation, Discovery turned out to be an interesting addition to testing. With Discovery, every test engineer can simply conduct a plausibility check in parallel. Discovery helps the test engineers to optimize the test methodology in advance. Discovery allows simulation and testing going hand in hand. If both point in the same direction, the certainty of being on the right track is greatly increased. We are aware that the July release is the first commercial release, but we clearly see the potential that the concept of Discovery fits very well with our goals. Discovery will help us to establish efficient variant analysis as a standard for our designers.
This is the new Discovery. And if you are just as enthusiastic about the model, explore, analyze in the new Discovery as we are here at CADFEM, then you now want to try it out for yourself. Of course, we have offers for you. On the one hand, you can of course also test the software. We guide and support you. We even have a cloud offer if you want to try it out. And you can go to our homepage where we have prepared a lot of information. But we also have webinars prepared for you. On the one hand, a webinar where you can see more of the mechanics, more applications, and also more details about the functionalities, but also about fluids. So, also a more look and feel and immersion in the functionalities of Discovery. And then something very interesting, perhaps more for the managers among you. We also have a webinar where we talk about the experiences other companies have already made. Specifically, Krones and Endress and Hausa, in the democratization process. In other words, the introduction of Discovery in the company. Or live simulation in the company. And that is of course an interesting story, if you can learn a little from others. To register there, please go to our Discovery section of our homepage. I am looking forward to meet you. Bye.